Good afternoon to all examiners and supervisors. My name is Fyp alias Paul and my matrix number is 72699. The title of my final year project 1 is Optimization of Solid State Fermentation Parameters for Silanase produced by Aspergillus species using agar waste as substrate. And my supervisor is Dr. Rosmawati binti Saad. This is the content of my presentation. Firstly is the introduction. I will be presenting about the introduction, which contains the problem statement and objectives. Next is the literature review, and then materials and methods, and expected outcomes and work schedule, then lastly references. I will be introducing about oil palm plantation because I will be using oil palm fronds as the substrate for the fermentation. This is the current situation in Malaysia. Oil palm plantation has the highest contribution value of 36.9 ringgit Malaysia, 36.9 billion ringgit Malaysia. And Malaysia also ranked 8 out of 10 amongst the Asian countries in agricultural sector. So by this high demand in market, government increased the land usage for planting oil palm by 5.9 million hectare in 2019. So the process of harvesting and processing oil palm plantation leaves a lot of residues and biomass such as oil palm trunks, oil palm fronds, mesocarp fibers, and oil palm anti-fruit bunch. So the residues are either burned or left in plantation. This causes environmental issues such as air pollution, water pollution, and soil erosion that will eventually lead to decrease in nutrient solubility in the soil. So one of the ways to decrease environmental issues is by converting these residues to other useful products or other applications such as enzyme production, waste management, bioethanol production, and juice clarification. So in this study, the agri waste will be oil palm fronds, and the species of the Aspergillus will be Aspergillus niger. The enzyme will be silanase, and the method will be solid state fermentation. And I also want to maximize the amount of silanase by optimizing incubation period, initial moisture content, and incubation temperature. This is the objectives of my this study is by determining the optimized incubation period, determining the optimized initial moisture content, and determining the optimized incubation temperature. This is the literature review of my study. So I will be focusing for the solid state fermentation. The benefits of solid state fermentation is I will be focusing on this: producing higher yields of enzyme and minimizing degradation of enzyme. And it is also suitable for filamentous fungi, since Aspergillus niger is a filamentous fungi. It has a quick coverage of hyphal, and therefore it will Aspergillus niger will easily gather up the nutrients, and it is also tolerant to low water activity since filamentous fungi lives in low water activity. And next, why is it important to study incubation period? Because prolonged incubation affects enzyme yield due to the decreased nutrients of substrate, release of toxin and protease, and drop in pH of substrate. So there are a few findings about the optimized incubation period, which for the Aspergillus niger and oil palm fronds is 7 days, and for the wheat bran and Aspergillus niger is 2 days. And next, why is incubation temperature is very important to be optimized? Because increased temperature leads to reduced growth due to the denaturation of enzyme. And meanwhile, low temperature causes slow transfer of cell membrane to substrate. And some of the findings of the optimized incubation temperature of oil palm fronds for Aspergillus niger is 78 degrees Celsius and 30 degrees Celsius respectively for activity and production of silanase. For different substrate and different fungi, for wheatbran is 36 degrees Celsius, for empty fruit bunch is 25 degrees Celsius, and for Trichoderma spirillum is 30 degrees Celsius. And next is the initial moisture content. Why is it important to optimize it? Because low moisture leads to decrease of solubility of substrate, and high moisture leads to water film being thicker. So this will lead to lower productivity of SSF. This is a few findings of optimized initial moisture content of Aspergillus niger and oil palm fronds is 60%. Aspergillus niger and wheatbran is 85%. And Rhizopus oryzae is 40%. Why am I choosing oil palm fronds? It's because the component has lignin, cellulose, and hemicellulose, which is the main component is the silan, which it will be degraded by silanase. Therefore, this is a very good substrate for the fermentation. And the other application of oil palm fronds is by enzyme production, red pigment production, and lovastatin production. For Aspergillus niger, the advantages of Aspergillus niger is to grow at low pH and produce high number of metabolites simultaneously. And one of the findings that it also recorded that Aspergillus niger has the highest secretion of silanase, which will be a good candidate for producing silanase. And other application of Aspergillus niger is citric acid production and protein production, such as hydrolases. Lastly is the silanase, which it will degrade silan to xylose. And the application of silanase is biobleaching, pulp and paper industry, enhancement of microbial growth, and juice clarification. This is the materials that will be used in this study. First is the oil palm fronds, Aspergillus niger, distilled water, petri dish, PDA powder, filter paper, flask, hot plate, stirrer, a silan, and Mendel's medium. This is summarized method of this study, which firstly is sampling and preparation of oil palm fronds, subculturing of Aspergillus niger, so it's SSF of Aspergillus niger, optimizing the parameters, extracting the silanase, and measure it using this formula. The expected outcomes, it is expected to obtain optimum incubation period of 7 days, and initial moisture content of 80%, and incubation temperature of 30 degrees Celsius. This is my work schedule. This is the reference used in my study. Thank you.